You know what it feels like to be on island time?
Oh, absolutely. Yeah.
Like you go on vacation, you leave your watch in the hotel room, and suddenly you are completely disconnected from the clock.
Right. The day just sort of flows.
Exactly.
Yeah.
It feels incredibly relaxing because your relationship with time fundamentally changes.
It is a profound psychological shift, honestly. You're voluntarily unhooking yourself from that rigid, linear progression of your daily schedule.
Yeah, the 9 to 5 grind.
Exactly. And you're just allowing your brain to exist entirely in the present tense.
But so here's the thing. What if that feeling of like playing fast and loose with time isn't just a vacation mindset? What if your brain is actually literally time hopping right now?
Which is a wild concept to even try and wrap your head around.
It really is.
Oh.
So today's deep dive is on a mission to explore a question that, frankly, sounds like science fiction. Can human beings subconsciously predict the future? We're looking at some wild research highlighted by Popular Mechanics today, including this astonishing EEG experiment that basically just shatters everything standard science says about linear time and human consciousness.
It completely upends the apple cart, yeah.
And reading through this material, my mind immediately went to that gut feeling. You know the one. I'm talking about that subconscious spider sense. Are we finally finding the scientific vocabulary for an experience humanity has reported for centuries?
Well, that is the core premise we're investigating here. Because historically, mainstream science writes those experiences off as pure confirmation bias.
Just a trick of the mind.
Exactly. The prevailing thought is that you simply remember the handful of times your intuition was, correct.
Right.
And your brain conveniently deletes the thousands of times you had a weird feeling and absolutely nothing happened.
Like, oh, I had a bad feeling about that flight, but it landed safely, so I just forgot about it.
Precisely. But the sources we're looking at today suggest there is measurable, hard data to back up that spider sense.
Which is crazy because that moves this entire conversation from the realm of like vague mystical intuition right into the concrete space of a laboratory.
It does. And to understand how you even begin to test something like a subconscious prediction, we really have to look at the work of Dean Radin.
Right, Dr. Radin.
Yeah, he holds a PhD in psychology, and he's an alum of Bell Labs.
Which, just for anyone unfamiliar, is practically the Mount Olympus of scientific research and development.
Oh, without a doubt.
I mean, Bell Labs is the birthplace of the transistor, the laser. They have multiple Nobel Prizes. It's a serious pedigree.
Very serious. Radin brings this tremendously rigorous, experimental mindset to phenomena that, honestly, most mainstream scientists won't even touch.
Because it's too taboo.
Exactly. It's seen as fringe.
Yeah.
But he currently runs his own research nonprofit, and he designed this highly specific experiment at the University of Nevada to test this exact concept of precognition.
So I was looking at how Radin actually built this experiment, and it's surprisingly straightforward for how bizarre the results are.
It really is an elegant setup.
Yeah. He takes test subjects, sits them in a chair in front of a computer screen, and hooks them up to an EEG machine.
Right.
And the EEG, that's an electroencephalogram, is tracking the physical firing of their neurons in real time.
Right. It's measuring the raw electrical activity of the brain before the conscious mind can even process a thought.
That's the crucial part, right?
It is. The setup completely eliminates the delay of conscious interpretation. The EEG is capturing the autonomic physical response of the organ itself.
So the subject is given this really simple task. They press a button, and a randomized image appears on the screen.
Okay.
And the images fall into 3 categories. They're either highly positive, completely neutral, or deeply unsettling, disturbing negative images.
Right. Standard psychological stimulus stuff.
Exactly. And because the computer selects the image at random the exact moment the button is pressed, the subject has absolutely no idea what type of image is coming.
And it's important to note the researchers don't know what image is coming either. It is a true double-blind scenario. There's no way to cheat it.
So when Radin analyzed the EEG data, he found this distinct, measurable increase in brain activity that occurred before the images were displayed.
Which is already strange.
Super strange. But here is the kicker, right? That pre-stimulus spike only happened before the bad images.
Yeah, that's the mind-blowing part.
When a positive or neutral image was about to play, the brain activity remained completely baseline, flat. But milliseconds before a disturbing image would hit the screen, the subject's physical brains showed a massive spike in electrical activity.
They were reacting to the negative stimulus before their eyes ever saw it.
Okay, wait, let me unpack this, because this is where my brain starts to hurt a little bit. The brain is bracing for a jump scare before the monster is even on the screen. How is the brain reacting to a stimulus that literally hasn't happened yet without completely breaking the laws of physics?
Well, that assumes our current understanding of the laws of physics, particularly when applied to human consciousness, is actually complete.
Which I guess it might not be.
Right. And Radin doesn't just, drop this jaw-dropping data and walk away. He offers a theoretical framework for how this could happen on a microscopic level in his book, Entangled Minds.
Okay, so how does he get around the fundamental arrow of time? Because an effect can't precede a cause. You can't flinch before the rock is thrown, right?
I wouldn't think so. But he looks to quantum mechanics to explain it. Specifically, the concept of quantum entanglement.
Oh boy. Quantum physics.
Bear with me. In physics, entanglement occurs when two subatomic particles become inexplicably linked. Whatever happens to one particle instantly and simultaneously affects the other, regardless of the physical distance between them.
Right, Albert Einstein famously called this spooky action at a distance.
Yes, exactly, because it seems to violate the speed of light.
So think of entanglement less like a signal being sent from point A to point B and more like two blank dice that are magically paired.
I like that analogy.
Like, if you roll one die in New York and it lands on a 6, the entangled die in Tokyo instantly becomes a 6. Space doesn't matter. The distance between them is irrelevant to the connection.
That's spot on. So Radin takes that established concept of spatial entanglement and pushes it a step further.
Okay, how so?
He proposes that these subatomic interactions aren't just isolated to sterile quantum physics labs, and they aren't just ignoring space, they might actually be ignoring time, too.
Wait, really?
Yeah. He argues that the microscopic particles making up the neurons in your brain right now could be entangled with the light particles hitting your eyes seconds in the future.
So is it like we have a subatomic internet router in our heads? Are these tiny particles acting as messengers, carrying a signal backwards from a future event to our present brain?
Basically, yes. The bad image on the screen in the future is really just a cluster of sensory data, right?
Right. Light, sound.
Exactly. So if the particles in my brain are entangled with that future data, my physical brain registers the shock before my conscious linear mind catches up. It provides a purely mechanical explanation for intuition. It isn't magic at all. It is subatomic physics bridging the gap between a future event and a present physical state.
So the brain is simply processing data that's arriving non-linearly.
Exactly. The information is already there at the subatomic level, just waiting for the macro-level organ, the brain, to catch up.
Okay, I have to play devil's advocate here, though, because this brings up a massive technical problem that skeptics always point out with this kind of theory.
Go for it.
Quantum entanglement is incredibly fragile. I mean, physicists go to enormous lengths. They use absolute zero temperatures, vacuums, heavily shielded environments, just to keep a few particles entangled for a fraction of a second.
Yes, you're bringing up the wet brain problem.
Yes, the wet brain problem. The human brain is a hot, wet, messy, chaotic organ. It's 98 degrees. It's constantly pumping blood and chemicals.
It is not a sterile vacuum.
Far from it. In quantum physics, that kind of environment causes something called decoherence. The thermal noise of the brain should instantly destroy any delicate quantum state. So how on earth do subatomic quantum states survive long enough in a warm organ to send messages from the future?
Well, you've hit on it. Decoherence is the primary wall between quantum physicists and neuroscientists right now. Mainstream science heavily relies on that exact argument.
Because it makes intuitive sense.
It does. The standard accepted view is that the brain is essentially just an organic classical computer.
Right.
It receives sensory inputs, light from the screen, sound from the speaker, and the neurons simply fizz around processing those inputs in a purely linear fashion.
Which means consciousness is the end product of the assembly line.
Exactly.
It's an afterthought. Your brain presents you with a summary of what just happened a few milliseconds ago, making it physically impossible to react to something that hasn't entered the sensory assembly line yet.
That is the mainstream view, yes. They insist the brain is too warm and noisy for quantum effects to scale up and influence our macro reality.
So what do they say about the EEG data?
Skeptics look at Radin's data and attribute the pre-stimulus spike to methodological flaws. They argue there must be subtle, unconscious cues in the environment that the researchers somehow missed.
Or it's just a statistical anomaly.
Right, a fluke.
But if mainstream science firmly maintains that the brain just fizzes around and consciousness is strictly an afterthought, how do skeptics explain away the replications of Radin's data? Do they just ignore the pre-jump scare spike? Because you can't just wave away data if it keeps happening, right?
You really can't, and that's one of the most fascinating aspects of this research. Radon's EEG results haven't just happened in a vacuum, they have been replicated by independent researchers.
And in science, if someone else builds the exact same experiment and gets the exact same anomalous result, you lose the right to call it a fluke.
Exactly. The documentation of precognition is vastly more robust than most people realize. And the Popular Mechanics article highlights a startling historical detail that gives this field serious institutional weight.
Oh, you're talking about the CIA's involvement.
Yes. In the mid-90s, the Central Intelligence Agency declassified a massive trove of documents related to their own studies on ESP, or extrasensory perception.
We are talking about the height of the Cold War here.
Yeah.
The U.S. government poured decades of research and millions of dollars into studying remote viewing, precognition, and anomalous cognition under programs like Stargate.
And you have to remember, intelligence agencies are remarkably pragmatic.
They aren't throwing away money for fun.
No, they are not in the business of funding science fiction. They were actively looking for tactical advantages against the Soviet Union.
Right.
So the fact that the CIA devoted sustained high-level resources to ESP indicates they were seeing anomalous data in their own classified trials.
They were chasing a thread.
A thread that suggested human consciousness could access information outside the bounds of conventional time and space.
So let's look at what we have here. You have replicated EEG data showing a physical brain reacting to the future. You have theoretical physics providing a possible quantum mechanism despite the wet brain problem.
Yep.
And you have declassified CIA documents proving that intelligence agencies took this very seriously.
It's a compelling trio.
It is. But if we accept that this data is real, it leaves us with a colossal problem. We have to essentially throw out the traditional clock. To make this work, we have to reimagine the fundamental nature of time itself.
We do. And that's where the physics gets really philosophical. The Popular Mechanics piece explores 3 distinct theories of how time and consciousness might overlap to allow for this kind of time hopping.
Because if an effect can precede a cause, time is definitely not just a flowing river.
Right. So the first theory they mention is retrocausality, which envisions time as a solid block. They call it the block universe theory.
Okay, the block universe.
In a block universe, the past, the present, and the future aren't things that happen in a sequence. They are simply different coordinates on a solid, pre-existing structure.
So it's all just there.
Exactly. The year 1990, the current moment right now, and the year 2050 are all squished together. They exist concurrently.
Okay, so is the block like a DVD where the whole movie already exists at once?
That's a perfect way to look at it.
Like if I'm watching Chapter 4, my experience of the movie feels like a linear progression.
Because you're in it.
Right. But the reality is that Chapter 5, the explosive finale and the end credits, are already burned onto the disc, existing at the exact same moment I'm watching Chapter 4.
Yeah.
The data of the whole movie is concurrent.
And because the entire movie exists simultaneously, the data from Chapter 5 can theoretically bleed into Chapter 4.
Oh, wow.
Yeah. The events are concurrent, allowing the future to impact the present. The neurons in the EEG experiment aren't predicting the future. They're simply accessing a coordinate on the block that is slightly further ahead.
You know, the philosophical implications of the block theory are honestly terrifying. And fascinating, but mostly terrifying.
How so?
Well, if the future is already burned on the DVD, it heavily implies a predetermined reality. It forces you to question the nature of free will. Like, are we making choices or are we just watching the movie play out?
It completely upends our sense of agency.
Yeah.
Which is why the second theory provides a slightly more fluid approach. It's called retrocausal consciousness.
Yoke?
Rather than a solid, unchangeable block, this theory suggests the relationship between time and consciousness is more dynamic. It posits that the future touches the past the way water ripples.
Oh, okay. So if the block is a DVD, the ripple theory is like dropping a rock into a pond, where the rock is a future event, and it sends ripples backward in time until they splash against our present-day minds.
Exactly. When you drop a heavy rock into a completely still pond, the ripples don't just travel forward in one direction, they radiate outward in 360 degrees.
Right.
So in the context of the experiment, the rock is the shocking, disturbing image suddenly appearing on the screen.
And when that high-impact event happens in the future, the energy of it sends these temporal ripples backward in time.
Yes. Those ripples travel backward until they splash against the present-day minds of the test subjects. The subject's brain is feeling the wave of the event a few milliseconds before the actual rock hits the water.
That makes so much sense. And it actually accounts for why only the negative images caused a spike in the EEG, doesn't it?
It does. Think about it. A neutral image is like dropping a tiny pebble.
It barely makes a wave.
Exactly. But a disturbing image is a boulder. It creates enough retroactive interference for the physical brain to actually register the anomaly.
Which leads us to the third theory mentioned in the sources, the loop.
Right, the loop.
What does it mean for time to function as a loop with a subatomic form?
Well, the loop theory heavily ties back to Radon's quantum framework and the concept of closed time-like curves in physics.
Closed time-like curves. That sounds complicated.
It suggests that time at the microscopic level doesn't travel in a straight line at all. It folds back on itself. If you travel far enough in one direction on a loop, you eventually end up right behind where you started.
So subatomic particles reacting to the terrible image on the screen are literally looping back around to interact with the neurons in the subject's brain moments before the button was ever pressed.
Yes. The cause and effect feed into each other continuously. The reaction creates the event, and the event creates the reaction.
That is dizzying.
It is, and it's vital to state that all three of these models, the block, the ripple, the loop, remain highly theoretical.
Right. They're just theories.
Yeah. Physics does not yet have the grand unified equation that perfectly marries quantum mechanics with macrobiology to prove retrocausality.
So we don't have the math to explain exactly how the rock sends ripples backward.
Not yet.
But we do have the EEG data showing the splash.
Precisely. We are left sitting in this incredible tension. We have a robust set of data pointing to a seemingly impossible conclusion, and theoretical physics frantically trying to build a bridge to make sense of it.
It really forces us to hold space for the unknown.
It does. The mainstream view that the brain just blindly processes the past is comforting because it's incredibly simple.
It's neat and tidy.
But the universe and the human mind are rarely that simple. The island time we feel on vacation might just be the very tip of the iceberg regarding how our consciousness interacts with the fabric of reality.
You know, I really appreciate how the Popular Mechanics article manages to take these massive, universe-bending existential concepts and just ground them back into everyday reality with a bit of humor.
Oh, the practical application they suggest is fantastic.
The takeaway is absolutely brilliant. The author basically says, the next time your boss gets furious with you about a missed deadline, you don't need to panic or apologize. You just blame your future self.
It is science, after all.
It is. The future version of you already missed the deadline in the concurrent block universe. So what were you possibly supposed to do about it in the present tense?
I have a feeling human resources might struggle to accept quantum retrocausality as a valid excuse for poor project management.
Look, if the CIA was willing to spend millions of dollars looking into it during the Cold War, HR should at least give me 5 minutes to present the ripple theory.
It might buy you some time, I suppose.
At least to confuse silence.
But on a serious note, grounding these theories really does make you deeply reevaluate the human machine.
It does.
We view our bodies as these clumsy linear vehicles, just sort of stumbling forward through time. But if even a fraction of this research holds true, we are incredibly sensitive, multidimensional instruments.
We're constantly interacting with the unseen architecture of the universe.
We are.
And that leaves me with a thought I honestly haven't been able to shake since parsing through this experiment. Something for you, listening right now, to maybe mull over on your own.
Oh. What stands out to you about the data?
It's the highly specific nature of the EEG results.
Okay, the bad images.
Yeah. Radon subjects only show that precognitive spike before the bad images. Their brains completely ignored the positive and neutral ones.
Yeah.
It raises this profound question. Is our ability to sense the future strictly an evolutionary survival mechanism?
Like a built-in temporal alarm system designed exclusively for threats.
Exactly. Like we evolved over millions of years to feel the retroactive ripple of the predator in the bushes. The brain time hops specifically to keep us safe from impending danger.
That makes a lot of biological sense.
But if that's true, if the biological hardware to sense the future already exists inside our skulls, imagine what would happen if we could flip that evolutionary switch.
What do you mean?
Well, what if we could train our minds to be just as sensitive to the good things? If you could learn to feel the ripples of positive future events, of impending joy, of success, of deep connection before they even happened, how entirely different would the choices you make today be?